Okay, this is the Unit 5. My cat's going to jump in here. This is the Unit 5 portfolio, plan ahead exponentially. So you'll need to go to the actual lesson, of course, and print out the worksheet and fill out the worksheet. I'm going to be working on my screen here, and I'm going to be working with Excel a little bit. Because I find it works really well when we're dealing with tables. So that's kind of where we're gonna go here. So the exercise is working with this formula. It's known as the compound interest formula. The amount in an account is equal to the principal, the amount that you put in the account, times 1 plus the recurring or the periodic interest rate, which is the annual interest rate divided by the number of compounding periods, all raised to the power of the number of compounding periods times time, or literally the exponent is the number of total number of compounding periods. Okay, so let me explain each one of these again. P stands for principal. 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 That's the starting amount. Okay, it's the amount in the account to begin with. Okay, R is the annual interest rate. Okay, and it is a decimal. It needs to be a decimal, not a percentage. Okay, N is the compounding periods. That is how many times we calculate interest in the year. The most common is monthly. The second most common is daily. Compounding periods. Okay, T literally stands for time, and it's measured in years. Okay, so that's a brief explanation of the formula. So part 1 asks you to kind of plan for the future. How much money do you want to have available when you retire? I'll give you a good ballpark figure. For me to retire right now would probably take having put away about $500,000 or more. That's just because you need to be able to live off the interest and live for a period of about 10 to 15 years, drawing off the interest and some of the principal, hopefully draining it down to zero by the time you reach the end of retirement. At what age would you like to retire? The younger you are, the more you need to save, because the longer you're going to be living on retirement. So $500,000, you guys probably be looking at the interest rates with the value of the dollar, etc. You're probably going to be needing in the tune of millions of dollars to to retire. All right, so it asks you to do some research for CDs. You may or may not find information. Kind of just look for what the common going rate interest rates are. Right now, the Fed's keeping the interest rates very, very low. And so you're going to find that they're so low that they practically mean nothing. A savings account right now earns maybe 0.5% interest or less. When I collect, I see interest statements on my bank account to the tune of 1 penny or 2 in a given month. So it's practically zero. So for the purpose of this exercise, let's do something a little more realistic. And let's say I'm going to let my interest rate, my annual interest rate on a CD. CD stands for cash disbursement, and you cannot actually it doesn't stand for cash disbursement. I'm forgetting what it stands for. Okay. But a CD you have to wait until it comes to maturity to withdraw the funds, or you pay a penalty. But you can get good money on that because they'll pay you more interest because they're guaranteed to be able to keep it for longer. Let's say we're going to use 4% as our interest rate. That's a reasonable interest rate. Sometimes In the 70s, interest rates were as high as 18%. Right now, I think the Fed has it held at about 2% typically. Let's say 4%. And we're going to play with some values here. Okay, so we've already defined the variables, and let's fill in the table. For the table, I'm going to use Microsoft Excel. Okay, do I already have Excel open? Apparently not. So Microsoft Excel, and here we go. And I'm going to just do a blank book, and that's kind of small, so I'm going to zoom 200% so you can see a little better. Okay, and we have time, and we have the amount in the account, and we have, oh, there we have calculations. So really time and amount is all we need. It wants you to show the substitution in the values here. Okay, and so we're going to enter 0, 5, 10, 15, 20, 25, 30, 40, and 50 years. So we're kind of looking at the interest over time here. Okay, let's resize a little bit. All right. Here, let's do this. Center it. Okay, there we go. And I'm going to center these as well. All right. So our interest rate, I'm going to insert a cell here. Insert a cell. And I'm going to insert some of the values. My interest rate is 0.04, which I can display as a percent if I want. But just click display, and it displays as a percent. Okay. And the amount in the account, the starting amount, I'm going to put that here. P is, they're just going to say we're going to start with $1,000. Okay, I do not want this cell as percentage. Okay, here, let's just use the format painter to copy the format. All right, $1,000. Okay, and format the cell as money. Boom. Okay, that's $10,000. I want 1,000. There we go. All right, and the time is in the table, so there we have our value. So let's enter our formula. To enter a formula in Excel, you're going to type equals. Okay, and we're going to start with the amount in the account, P. So I'm just going to use the arrow keys to go up to P. Notice for me it's cell B2. Times, that's shift 8. Parentheses, 1 plus. The periodic interest rate is R, so I'm going to move up to R. Now note it's 4%, but the formula is going to treat that as 0.04. Divided by N, the number of compounding periods. And actually, I just realized I didn't put that in. So let's add a new row. N compounding periods. We're going to say it's compounded monthly. So we're going to have 12, and that is not a dollar amount. Okay. Remove formatting. There we go. Okay. All right, now we're ready. So the amount is the principal times 1 plus the interest rate divided by 12, well, divided by the compounding periods, to the power of, that's shift 6, and then open parentheses, because this is all the exponent, the number of compounding periods times the time. Now the time is right here. Close parentheses. Okay. And let me check the formula here. B2, B1, B3. A7 is the wrong one. It should be A, yeah, that's what I thought. A6, I thought that happened. Okay. All right. So we've started with times 0 and the amount is 0. Now there's the cool thing about, now I could go through and type that formula for every cell, but the cool thing about spreadsheets is I can copy and paste. But in order to copy and paste, I'm going to have to do something called absolute cell references. So cell B2, I always want that to refer to cell B2. So I'm going to hit the F4 key, and you're going to see $B, $2. The cell B1, I always want that to refer there, so F4 for that. That's called an absolute reference. B3, I always want that to refer there, so F4 for $, and B3. The only one that doesn't have $signs is A6, which is our time. Okay, so now if I hit Control C and drag down and Shift, or I can use my mouse to highlight, and Control V to paste. There we go. Okay, so we see each of our amounts. And the cool thing is I didn't have to calculate each one by hand. So if you can figure out how to do this way, great. If you need to use your calculator, that's all right. That's all right. It'll just take a little longer. Okay, so let's see what we notice a little bit here. We've got 4% interest, and at the end of 50, oh, not 50 years, I have 20. It used to be 50. At the end of 50 years, my $1,000 has grown to a little over 7 times. Okay. By the way, if you do this and you come out with millions of dollars or billions of dollars, you goofed. Okay. So make sure your answers are reasonable. I've seen some rather extreme answers on here. Okay, will we be able to reach our retirement goals this way? The answer obviously is no. We need something more. Okay, now the rest of the exercise, the rest of the worksheet asks us to analyze the effect of changing. We're going to hold each of the variables constant except for one, and we're going to let one change, right? So we're going to do this. I want to hold the principal. I'm going to let it vary. Okay. And I'm going to let it vary. I'm going to let it be 1,000. I'm going to let it be 2,000 and 3,000. Okay. My interest rate, and I'm just going to do P and R. And my interest rate is going to be 1%. Okay. And my compound frequency is going to be 4. So this is known as quarterly, so 4 times a year they calculate interest. The account balance is what? Okay, so let's center. Boom. All right, and let's enter our formulas. So equals principal times parentheses 1 plus interest rate divide the number of compounding periods to the power of the number of compounding periods times time. Now time, they don't have a cell for time, so they said for 50 years. Use 50 years for time. Okay. Now this dollar amount doesn't make a lot of sense, so we can choose to display this as money. That was percent, not money. There we go. And when we do, it rounds to the nearest penny. So $1,647.69. Okay. Now the cool thing about this is since I have each of my variables in each row, I don't need to worry about absolute or relative cell references. I can just copy and paste. Copy, paste, because the cells will update. So you notice by tripling the starting amount, we about a little more than doubled the amount of money we earned. Okay, so that has some impact. All right, so let's do this now. Let's say the principal is $1,000. Okay, and the interest rate is, we're going to let the interest rate vary, 0.01, 0.02, 0.03. And we're going to hold the compounding periods at 4. Cool thing is, I've already typed this up, so copy and paste. Okay, and notice this has pretty good effect, pretty good impact, but not quite as much as doubling and tripling the amount that we invest. So the biggest factor in how much money you make is how much money you put in. The second biggest factor is the interest rate. Okay, and that actually changes over time. Interest rate has bigger weight the longer you leave it. We're leaving it for 50 years, which is a pretty good time. Okay, and then they have you do this. They have you hold the principal at $1,000, so the principal is constant. Okay, and the interest rate is 1%. Okay, but they change the compounding periods. They do it quarterly, they do it monthly, and they do it daily. Okay, and let's see what difference that makes. And you'll notice it makes almost no difference at all, which is kind of surprising to a lot of people. So the more often you compound, the more you make, true, but not that much more. The difference between compounding quarterly and compounding daily looks like it was just a little over $1.02. So not enough to shake a stick at. Okay. All right. So hopefully that helps. You feel free to use a spreadsheet. You can turn in an Excel file. You can turn in a screenshot of an Excel file. You can turn in a Google Doc, a Google Sheet if you want. You can do this on paper. You can take a picture of your worksheet. Let me know if you have any questions.